or elementary? No, we've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Singh, and I am one of the math specialists here at Learning Liaisons. And it is always a joy, always a pleasure to be here with you guys. I just absolutely love being here doing Wednesday Night Math sessions with you. And like he said, our job here is just to really support you in your endeavors to taking these really difficult math exams. Let's be honest, they're not easy. Our goal here is just to give you a little taste of what we offer at the Learning Liaisons, give you a little taste of some of those boot camps that we offer or whatever, and really just provide you with some free math prep problems tonight. So I'm going to go over about 10 problems tonight. And as always, if you have any questions at all, please don't hesitate to drop it in the comment box. It makes it more fun for me because it makes me feel like I'm not looking at a computer screen the entire time. So it makes it feel like it's a little bit more interactive. But it also really helps tailor these sessions to you rather than making it feel like it's just like a scripted program. So if you have any questions, let me know. If you want to see me go over anything in the upcoming weeks, let me know. And I always like to do a get to know you before we get started, just because I like to get to know who's in the room, and it helps me tailor my rabbit trail conversations. Like I said, the problems are pre-done already, but it helps me kind of tailor what kinds of trails we go on. So in the comment box, let me know where you're from, what test are you prepping for, and if you've ever seen Ice Age or The Incredibles, which one is the better movie? I have actually never seen either. They are two of my husband's absolute favorite children movies, and I've not seen either. And I'm a huge Disney fan. I'm a huge children's movie fan. I'm a huge Pixar fan, like all the things, and I've never seen either one. So do you like Ice Age or The Incredibles better? If you've never seen either, just, I guess, what is your favorite kid movie? I would have to say probably Monsters, Inc. is my favorite. Either that or Finding Nemo. I don't know. I grew up in that era, like Finding Nemo, Cars, Monsters, Inc. And so I would definitely have to say Monsters, Inc. Hey, Melissa, it's good to see you. Ice Age, I would say good choice, but I've never seen either one, so I can't really say whether that's a good choice or not. I'm definitely going to have to watch them this holiday season when I have some time off, just since they're my husband's favorite, and we've been together for 10 years. So definitely going to have to do that. All right, so I always do like a next week section, so I am going to get that ready so that as you guys comment and let me know what you want to see me going on next week, I can always add them to this list. Last week we had some people suggest that they wanted me to go over word problems, ratios, percentages, decimals. Have word problems tonight, have ratios, decimals, percentages tonight, and fundamental counting principle. I have a problem on fundamental counting principle. Not my favorite problem. We will do it, and I will probably add another one next week. But we will definitely do it. Fundamental counting. Hey, Chris, it's good to see you. Incredibles is very good. That's what my husband keeps telling me. Maybe we should be the Incredibles next year for Halloween. That's what I'm thinking. Also, this is totally random. Did you guys know that a Stanley Cup, this little piece twists and you can drink out of the side of it? I thought a Stanley Cup only had like a straw hole, but you can twist it and it has this open hole that you can like drink from. Who knew? Can I also do nth term? So like what is the 922nd term of this sequence? Yes, absolutely. That's a good one. Nth term in series and sequences. All righty, let's go ahead and get started with our first problem. It's that fundamental counting principle problem. We're going to start out the gate with fundamental counting principle. If you are here and you are watching and you were like, I came for the elementary math, where is that? I promise it's coming. This is not what the entire night is going to be about. Don't let this problem fool you. Don't let it scare you away. So here we go. I have two of these. So we're going to do two of these and then I promise we'll get to some easier stuff. So let's read it together. You go to check out 3 books at the library and you want 1 fiction book, 1 nonfiction book, and 1 mystery fiction book. The library has 64 fiction books, 23 nonfiction books, and 35 mystery fiction books. How many combinations of books do you have to choose from? All right. So if you have no idea how to do this problem, here's where I want you to start. I have 64 fiction books. So if I list all of those books here, these are all of my fiction books, 64 of them to be exact, right? And then I have 23 nonfiction books and 35 mystery books. I want you to think about this. If you have no idea where to start, if I choose this book off of the shelf, 1 out of 64 books, I could choose any of these 23 nonfiction books, right? And then if I choose one of those nonfiction books, I could choose any of these 35 mystery books. And that's just one fiction book, choosing the top nonfiction book, and there's 35 options. Then let's move down to the next book, 35 more options. Then let's move down to the next book, 35 more options. Then let's move down to the next book, 35 more options, and we've still only chosen the top fiction book. So that said, is 122 a reasonable answer? Is 122 a reasonable answer? No, not at all. Because I'm trying to figure out how many different combinations I have. Basically, the fundamental counting principle says, in this kind of situation, we're just going to multiply these numbers together. because out of 64 fiction books, there are 23 options that I have for nonfiction books. So just for the fiction and the nonfiction, this is how many options there are. And then on top of that, I have 34 mystery books. So then I have to multiply all of those options into the options that already exist, which create a ton of options. And I am sharing my screen. You know, we're just going to roll through it. If it just disconnects, I'm just going to continue chatting away about math and I'll just reconnect it. For those of you who are new with us, welcome. My iPad loves to disconnect from StreamYard. I don't know why, but it just does. And so here we are, and it's just going to do that. So after I figure out how many fiction and nonfiction options I have, I then have to take those options and multiply that by the number of mystery fiction books, which is 35, not 34. So when I multiply all of those numbers together with my calculator, 64 times 23 times 35, that equals 51,520 options. That's a lot of options, which is D. Now, let's look at one that's a little bit different. Now we're at a spelling bee. And students A through G, A, B, C, D, E, F, G, sit in the seats on the stage. If there are exactly 7 seats, 1, 2, 3, 4, 5, 6, 7, how many different ways can those students be seated? So here's where you have to kind of discern what's going on. If there are exactly 7 seats on the stage, how many different ways can we seat them? How many options do I have for this seat right here? Who can sit there? A, B, C, D, E, F, or G. So there are 7 options for that seat. How many options are there for this seat? A, B, C, D, E, F, G. It's tempting to say, well, there's 7 kids. And at that point, you could have any of them could sit there. And any of them could sit here. And any of them could sit here or here or here or here. You're right. However, once a student plants their seat or their bottom in a seat, so let's just say student C is sitting here. How many students are left to sit in this seat? 6. I can't repeat students. I can't have student C sitting in seat number 1, 2, 3, 4, 5, 6, and 7. So now let's pretend F is sitting here. Now how many options are there? 5, then 4, then 3, then 2, then 1. This is an example of fundamental counting principle with no repetition. I cannot have my students repeating in this fundamental counting principle problem because student C is not a clone. He can't sit in all of the seats at the same time. Hey, Marco, it's good to see you. So 7 times 6 times 5 times 4 times 3 times 2 times 1. I can also write this as 7 factorial, which is the 7 exclamation point. So anytime we see a factorial, it means take that number and multiply it by itself that many times. So, no. I'm sorry. That was a terrible way to explain it. 7 with an exponent means multiply 7 times itself that many times. 7 factorial means take 7 and then 6 times 5 times 4 times 3 times 2 times 1. Or 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, there are formulas with factorials. There are formulas with factorials for like permutations and stuff like that. But this is a factorial, not necessarily a permutation. In what I'm describing. Chris, is this an example of a permutation? A permutation is a set of or an arrangement of members. Yes. So I guess technically loosely this could be a permutation. Yeah. I don't want people to get confused because there's actually a permutation formula, which is like n factorial divided by parentheses n minus r factorial. So like it's not necessarily that, but like anytime we have a loose organization of items, yeah, it could be considered a permutation. That was a good question. So anyways, all that said, let's do that in our calculator. 7 times 6 times 5 times 4 times 3 times 2 times 1, 5,040, which is B. All right. I promised you that we wouldn't do this kind of stuff the entire time. That is the last fundamental counting principle problem that we have today. But let's go ahead into something a little easier. So last week we did the gym offering 2 monthly plan problem. I want to now look at the gym monthly plan problem with a difference. So the gym offers 2 monthly plans. Now this one does not have multiple choice. There are tests out there that don't have multiple choice. So I don't do these very often where we do a fill in the blank. But I just kind of wanted to do one with a fill in the blank today. A gym offers 2 monthly plans. Plan A costs $10 per month after an initial $99 fee, while Plan B costs $22 per minute of calls. That should say per month. No, this problem is not going to work because this says what is the difference in the two plans after 8 months. So we're going to say $22 per month, because otherwise that's not going to work unless we know how many minutes they've talked, right? So we're going to say $22 per month after an initial $15 fee. So Plan A has a higher initial fee but a lower per month. Plan B has a higher per month but a lower initial fee. What is the difference in the cost of the two plans after 8 months? So in order to solve this problem, we have to understand vocabulary, basic vocabulary. And that's where most people get tripped up when they are solving word problems. They don't necessarily understand what the problem is asking. So when we see what is the, oops, I didn't mean to erase that. When we see what is the difference means subtract. Now, I do not like teaching keywords. Don't get me on my keyword soapbox. But you will not see me explain using keywords very often. But what I know is that difference means subtract. And in the context of this problem, I know I'm going to have to subtract the two plans after 8 months to find that gap or that difference between the two. So let's go ahead and start with Plan A. Plan A, I know it's $10 per month. So I need to do 10 times 8 because we're doing 8 months of this plan, which equals 80. But I also know that I need to add that $99 initial fee. So when I add $99 to $80, I get $179. So this is how much that plan costs after 8 months. Let's go ahead and look at Plan B. Plan B costs $22 per month. There's that $8 again, or 8 months. I'm going to multiply 22 times 8, and I get 176 plus my $15 initiation fee, and that's going to equal 191. Which plan is a better plan after 8 months? Plan A is a better plan. They didn't ask us that question, but I always like to throw that question in there. They asked us, what is the difference? So I need to take my 191 and subtract the 179 from the 191, and that's going to give me $12. So my answer to this problem, what is the difference, would be $12. This could absolutely be found on an elementary K through 6, GK, any test like that exam. You could find this on there. This is a really good word problem, comparison problem, all of the above. All right, let's move on to, ooh, this is a good one. This is a good one. A pool company is building a rectangular pool with a deck that measures 6 feet all the way around. The pool will measure 14 feet long by 18 feet wide. If the deck costs $3 per square foot, how much will the deck cost? So this is one of those multi-step problems because we have to figure out the area of the deck, and then we have to multiply the area of the deck by $3 per square foot. Now, do I need to do any sort of conversions for this problem? No, they didn't say it costs $3 per yard. They didn't give us the pool in inches. So in that respect, we do not need to do any conversions, which is a good thing. But it's always something that I pay attention to because it's something that test writers love to throw in there to trick you. So I want to make sure that when you're looking at problems like this, especially these multi-step problems, make sure that there's no conversions that you have to do. So area of the deck. I've got a rectangular space. And then I've got a pool inside of it. And that pool is 14 feet by 18 feet. Does it matter if you put the 14 here and the 18 here, or you put the 18 here and the 14 here? It doesn't matter because everything that we're doing is like multiplication, addition, subtraction. So it's commutative, which just means you can do it in any order, which just means it's not going to matter. So 14 times 18 is going to give me the area of the pool. But that doesn't necessarily help me figure out the area of the pool deck. So I need to figure out what this whole length is. Can anyone help me figure out what that whole length is? What am I going to do? Well, if I know that this section is 14, because this right here is 14. What else do I also know? What do I know about the deck? I know that the deck measures 6 feet all the way around. So what does that mean? That means that this is 6. That means that this is 6. This is 6 all the way through. And this is 6 all the way through. So if this is 14, because that's the pool, then I know that this is 6 because we just defined that the width of the deck is 6 all the way around. And I also know that this is 6 because it's 6 all the way around. So then what is that entire length that we have? 14 plus 6 plus 6 equals 26. So this whole thing is 26. The number one mistake people make on problems like these is they forget to add the 6 on the top and the bottom. They only do 14 plus 6. They forget that there's a deck on the top and the bottom all the way around. So I'm going to do the exact same thing for this piece. This blue section is 18 because that's the pool, but then I have 6 over here and 6 over here. So 18 plus 6 plus 6 is 30. And now I have the entire distance of that brown rectangle. So what am I going to do? There are 2 ways we can do this. I could find the area of this smaller rectangle and this smaller rectangle. And then I could find the area of this rectangle and this rectangle and add them all together. Or I can find the area of this entire big brown rectangle and then subtract out the pool. That's going to be the way I choose to do it, but you might choose to do it a different way. So I'm going to find the area of the whole big rectangle. So the area of the entire brown rectangle is going to be 26 times 30, which is 780. Then I'm going to subtract the area of the smaller blue rectangle, which is 14 times 18, which is 252. So 780 minus 252 equals 528 square feet. Now what? That represents the area of just the deck because I did the whole brown rectangle and then I subtracted out the pool. But that is not there. So what do I need to do now? I need to figure out what it costs. So if the deck costs $3 per square foot, what do I need to do? I need to multiply my deck times 3. So now I'm going to multiply this times 3, and I get 1,584, which is C. Excellent job, y'all. All right, let's go ahead and move on to our next problem. If you have any questions at all, please don't hesitate to ask. If you have anything you want to see me go over next week, please put that in the comment box. All right, next problem. In a school, the ratio of boys to girls is 4-5. If there are 672 total kids in the school, how many boys attend the school? All right. So there is a very common problem that happens, and I'm going to show you what it is. This is the common problem. People go 4/5 equals x over 672, and then they cross multiply 5x, 672 times 4 equals 2,688. Divide both sides by 5, and x equals 537.6. First of all, that answer is not there, so you would know you did something wrong. But that is going to be the number one mistake people make. Why? Because that people assume that that's how a ratio works. But actually, a ratio, yes, that is how ratios work, but we have to look at what the ratio is representing to its core. So, what is the ratio actually representing? The ratio is of boys to girls. So this is my boys, and I'm going to do B for boy, and this is my girls. So what that means is that for every 4 boys, there are 5 girls. That is my ratio of boys to girls. But then what did it say next? There are 672, I don't like that color, 672 total kids in the school. When I am setting up equivalent relationships or equivalent ratios, I have to make sure that what I'm comparing is the same. So by doing 4/5 equals x over 672, what you're actually comparing is boys to girls equals boys, how many boys, that's your x, to what? Total. These don't match. And in order to set up equivalent ratios, I need them to match. I can't do 4/5 equals x over 372. I need to do boys to girls, girls to everyone, boys to total. Like, I have to compare apples and apples. So instead of this, I need to do boys to total equals boys to total. Why did I pick that? Why didn't I pick boys to girls? Because they asked for boys, so that needs to be one of them, and they gave me a total, so that needs to be the other. But you're like, wait a minute, the ratio they gave us is not a total. It's boys to girls. You're right. But can I figure out my total within that? Absolutely. So let's take our smaller ratio here. Boys is 4. How many total kids are in that ratio? How many total kids are in that ratio? 9. 4 plus 5 equals 9 equals boys 2 total. So now let's cross multiply. Now we can go through with all those steps. 9x equals 4 times 672. 9x equals 2,688. Divide both sides by 9. X equals 298.67, which rounds up to that 299. So the answer is C. Interesting question, right? Like, not typically what you think of when you think of a ratio problem. All right, someone specifically asked for ratios, hence the star. Let's go ahead and move on to the next problem. And that same person asked for percents. So let's go ahead and look at a percent problem. You'll see it says 4B. I'm going to go back to 4A in a minute. As a part of a survey, 1,200 people were asked to name their favorite sport, where the table and the graph present the results. What percentage of the individuals surveyed chose baseball or football as their favorite sport? What percentage of the individuals surveyed chose baseball or football as their favorite sport? This is an interesting one. So I'm trying to figure out a percentage. What is a percentage even? A percentage is a part of a whole, a part out of a total, right? That's really what a percentage, a fraction, all of that is. So remember, we can convert between fractions, percentages, and decimals. Fractions, percentages, and decimals are really all one big happy family. So I am going to write our big happy percentage, fractions, and decimals are one big happy family. So I need to figure out my part of my whole to be able to figure this out. So they told me that 1,200 people were asked to name their favorite sport. So what is my total going to be? If I'm thinking of this as a part of a whole, what is my whole? My whole is 1,200 because that's how many people were surveyed. Now, if I have time, I'm going to add all of the people that are represented in the graph just to make sure they're not trying to trick me. I'm going to pretend I don't have enough time. I also know that that equals 1,200, so I'm not going to waste my time right now. But I know it's out of 1,200. Now, what is the part that I'm looking for? Baseball or football? So I'm looking for this or this, which is 132 and 312. Now you're like, Amy, that's a fraction. Oh, I know it is. I'm going to show you how to convert that fraction into a decimal. So let's go ahead and add 132 plus 312. That equals 444 out of 1,200. Now, if I have a calculator, I can literally punch that into my calculator to figure out my decimal. This is a division problem. What I don't want you to do is punch in the wrong thing. So watch how I'm going to punch this in. I'm going to make myself a little bigger. Watch how I'm going to punch this in. In my phone, I'm literally, let me see if I bring the, okay, that didn't work. In my phone, I'm literally going to put, I'm trying to mess with my brightness to see if it helps. 444 divided by, I just hit the division sign, 1,200 equals 0.37. I caution you in punching 1,200 divided by 444. Sometimes our brain thinks, I can't divide a little number by a big number. If it's a fraction, absolutely you can. Numbers can be divided in any way. It doesn't matter. But our brain likes to think we can only do 1,200 divided by 444. So 0.37, there's my decimal. I have my fraction. Now I have my decimal. How do I convert that into a percentage? Hop that decimal 2 places to the right. That's going to give me my percentage. So that gives me 37%. All right. Let's take a look at how this problem could be elevated for my high school people. Let's take a look at how this problem could be elevated. So this is the way that they might ask this problem at the elementary level. How are they going to ask it at the high school level? Whoops, I went the wrong way. Let's go back to 4A. As a part of a survey, 1,200 people are still asked what their favorite sport is. Find the central angle for the portion of the circle graph representing baseball and football combined. Find the central angle. The central angle is defined as this angle right here and this angle right here combined, right? So I'm going to take everything I just did. I'm going to copy it because a lot of this is necessary There we go. A lot of this is necessary for us to be able to solve this problem. And there's no reason for me to just rehash what we've already done, right? So in order to find the central angle, I needed to figure out what percent football and baseball were taking up of the graph. Then the only next step we're going to do is figure out what that is out of an entire circle. How many degrees are in a circle? How many degrees are in a circle? 360. So I need to figure out what is 37% of 360 degrees. How do I figure that out? Well, multiply 360 times the decimal form, 0.37 of 37%. So multiply 0.37 times 360, and I get 133.2, which leaves me with that as my answer. So they can take this problem and definitely elevate it for my high school people. So this is why I love knowing what tests you're taking, because it allows us to really see that they can use the same data and ask a different question. Pretty cool, huh? All right, this one's a fun one too. What is the equation of the line in standard form that is perpendicular to 3x plus 5y equals 30 and has the same y-intercept. So the number one response that is going to be the incorrect response, like the number one error people are going to make, is choosing this one. Because they're going to go, oh my gosh, I remember perpendicular lines are opposite. So it has to be a subtraction problem. And if it's going to have the same y-intercept, that's definitely the y-intercept. So it's got to be this one right here. And they have the same 5. So that's definitely going to be the answer. So that is actually not the answer. That is not how we solve this problem. Let me show you how we're going to do this. Standard form, earth to everybody who has to know anything about lines. Standard form is not helpful. It's just not. Standard form gives us no information. So let's take a look at what does. Y equals mx plus b is my slope, intercept, form. And y minus y1 equals m times x minus x1 is point slope form. Now, this one right here is going to be the most helpful because I can easily take this, put it into that, and figure out what the slope is and what the y-intercept is. Once I do that, I can figure out which of these is going to be my answer. So 3x plus 5y equals 30. Let's go ahead and put this in slope-intercept form. You're like, how do you do that? Well, slope-intercept form has y by itself. So I need to do everything in my power to get the y by itself. So the first thing I'm going to do is subtract 3x from both sides. Why not divide? Because I'm trying to isolate the 5y. And what is being done to the 5y is 3x is being added to the 5y. So I need to subtract the 3x. Can I do 30 minus 3x equals 27x? No, because I can only add and subtract like terms. So 5y equals, watch what I'm going to do, negative 3x plus 30. Why did I just do that? Because I want my x term to be first. Now I'm going to divide both sides by 5. Everything gets divided by 5. And y equals negative 3 over 5x plus 6. Now, what is the perpendicular slope? Because remember, I did this work so that I could see my slope and my y-intercept. So they're asking, what is the equation of the line in standard form? These are all in standard form. That is perpendicular. Well, I know perpendicular slopes are negative reciprocals. I'm going to say that again. Perpendicular slopes are negative reciprocals. So that means if I have an A over B slope, the perpendicular one is going to be negative B over A. So my new and improved line is going to be y equals positive 5 over 3x. And then what is my y-intercept? 6. Because they have the same y-intercept. What does it mean if they have the same y-intercept? That's their intersection point. So if we were to graph this, these perpendicular lines would cross at that y-intercept right there. But that's beside the point. So y equals 5/3 x plus, y equals 5/3x plus 6. Now, what do I need to do to get it back into standard form? Well, I need to subtract the 5/3 x from both sides because now I need it to be x plus y equals something, right? So I need to do negative 5/3 x plus y equals 6. Now you're looking at me like, all right, Amy, you have x plus y equals 6. Why is my answer not there? Because in standard form, your first value, that a value that's in front of the x, cannot be negative or have a fraction. That first value, that a value, cannot be negative and it cannot be a fraction. So I need to multiply everything by a negative something. We were so close to finishing. All right, I'm going to reconnect for the last little bit. Now it doesn't want to reconnect. All right, let's just finish this problem like this then. So, where was I? I need to multiply it by a negative something. I'm going to multiply everything by a -3. Why? Because it'll turn this into a positive, and 3 divided by 3 is 1. So that's going to cancel my fraction out. So I'm ending up with a positive 5x. Then the -3 goes to the y, minus 3y equals, then the -3 distributes to the 6, -18. So my answer is B. All right. What do you all want to see me review next week? Let me pull back up my next week slide. I have fundamental counting again. I have the nth term in a series or sequence. What else do you want to see me go over next week? And I will add it to my next week's slide. Like I said, this is for you. This is not for me. I'm about to lose my voice. This is for you. This is not for me. So I need you to help me out by saying, what do you want to see from me? Another number 5 problem. All right, once it figures out how to connect, let me go ahead and take a look at what problem that was. Oh, another perpendicular, parallel, linear equation kind of line. Yeah, absolutely. Those are so fun. I love those. I will absolutely do another one of those. That's good. And I'll try to make it like, I'll do one that's similar and then I'll try to make one that's a little harder. So I'll just put C number 5. Parallel, perpendicular. My iPad does not want to stay connected. My iPad's like, we're done. We're all done for the night. Perpendicular line, relationship, all of that. Awesome. All right, I am going to turn it back over to Dr. A. I will stick around for any questions that you might have and for anything else that you want to see me work through next week. And we will see you next week. And then I'm just going to let you all know, we are not going to meet the Wednesday before Thanksgiving. Listen, we've got stuffing and turkey to prepare. So we will not meet the week before Thanksgiving. We will meet next week. We are not going to meet the Wednesday before Thanksgiving. You are so welcome, Marco. I'm going to turn it back over to Dr. A, and I will see y'all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.